This is a Bedini motor built on a 20-inch wheel that came off an exercise bicycle, which I was able to purchase for $5. It had a solid tire, so I mounted the magnets. It's got 20 magnets right on the tire. One of the problems you have when you build one this large is where do you put it? Right now you may be able to recognize what it's sitting on. It's a washing machine, because it was the biggest clear spot in my workshop. It's been running a little over half an hour right now. It's running about 90 RPM. Oh. Well, I'm not getting a reading yet. I'll probably have to get in front of it. It's showing 89.6 right now. It's still, what I'm trying to do with this one is get it to charge the battery it's running with. You can see it's running on a single 9-volt battery here. That's a rechargeable battery. It's got 3 coils that are Trifilar coils hooked up in the run windings are hooked up in series on these 3 coils, and the other 2 windings in each of these coils are going down to a bridge rectifier, each on a separate bridge rectifier, and then to the there's a couple of capacitors back here. I may try and move this around a little later to show you what's going on. The additional coil here is the Trigger Coil, and this is a bifilar coil, one I had lying around that I hadn't used, and I connected both of these windings in series, and this is only being used to trigger the transistor. These ammeters here, one is showing what it's running on, which is, because it's a pulse, it's hard to measure this accurately, but it's showing about 50 milliamps. This ammeter is showing the pulses going back into the battery. And what I've done here is I've got 2 micro switches, and I've got cams on the shaft on the rotor here, and one of these micro switches is shutting off the voltage to the run circuit, and the other one is turning on the voltage that's charging back into the battery. The cams are timed so that the action occurs between 2 magnets passing the coils. In other words, it's on the break between 2 magnets. This voltmeter is showing the run voltage. When you initially start this, it jumps up and down continuously, and then it starts to stable out. This is showing the charge voltage. It's been running over half an hour right now. I don't know how long it'll run on this battery. I'm sure it'll extend the run time because I am attempting to charge back into the battery. One of the problems is that you're trying to overcome here is charging the battery while it's being used, and that's the purpose of these switches. I'm trying to switch off the run circuit and switch on the charge circuit at the same time. Let me see if I can zoom in a little here. There's the 2 voltmeters. There's the 2 ammeters. Don't know how well those are coming in. But it's been fun to build. One thing I'm still going to do is put an axial flux generator over on the back side of this. There's a pulley there that takes a 1/8 inch belt, and the axial flux generator will be mounted on this rail here, and I'll see if that helps any with the charging, or at least I can run some LEDs, make it look like it's doing something. This circuit is basically the same circuit that I showed in my previous 3-coil Bedini. Except that I've added the 4th coil just to trigger the transistor. I'm using a 2N2222 transistor. I didn't see any reason to use the larger one because the 2N2222 can handle up to 200 milliamps. I'm going to remove this camera here, so it make it a little jerky. Trying to get it off the tripod. There we go. So you can see a lot of wires there into a breadboard circuit and 2 capacitors. I tried using some supercapacitors, but I don't think that helped any because they take so long to charge, and you need to be able to have enough voltage to push the charge into the other battery. So although they could store a lot more, I don't think they were charging up fast enough in the cycles here. This 4th coil here is advanced about half the width of the core, and that made it run about 20 RPM faster. I'm going to shut it down now, just so you can see the magnets on the wheel. This battery was reading 9.1 volts when I started. So you can see it's still slowly discharging. Not sure what this is reading right now because it still shows a voltage. Although if I turn the wheel when it's not connected to the battery, both voltages go up. I think I got dirty contacts in that meter. Okay, so that's what the battery still has on it, is 8.83, so you can see it has discharged slightly. These magnets that I got, I think they're about 2 for $1 at Harbor Freight. Filament tape is around them to help keep any magnets from flying off, and also to help with the aerodynamics, give it a smoother surface as it's turning around. I'll make another video once I get the Axial flux generator hooked up. I'm still waiting on some disc magnets to complete its build. Come back soon.